In this video, I'm going to go through a practice dependent t-test scenario and analysis. I would suggest that you open up SPSS and put the data into it and follow right along, and stop the video whenever you want to for each step and try it out for yourself. So let's look at what the situation is, which comes right out of your textbook. It's about a conservation campaign that the government's considering. So it conducts an experiment by randomly selecting 11 families from an area and monitoring the amount of gasoline they use before the campaign and the amount of gasoline after the campaign. And this is the data that they collect. So the first thing I do is decide what kind of analysis am I going to do and why. So I have to look at the original research question here. What we're trying to find out is we want to see if the change from before the campaign to after the campaign is significant. In other words, was the campaign effective? So I want to see if there was a difference in the fuel consumption before and after the campaign. I have the same subjects being measured before and after. It's 11 families. They get measured before, the amount of gasoline they use, and after the campaign. So they're correlated. I decide I'm going to use a dependent t-test or a paired samples t-test. And here's how I'd write it up. This study was done to determine if a conservation campaign would impact the fuel consumption of families. 11 families were randomly selected from the same geographic area. Their fuel consumption before and after the campaign was measured in gallons per month. A paired samples t-test was used to determine if the change in fuel consumption was statistically significant. The test was dependent because the same families were used before and after the campaign, so the means were dependent or related. Now I'm going to take a close look at my data. First of all, my independent variable. My independent variable is going to be this campaign and the time before and the time after. So it's going to be a measurement of time. And the dependent variable, let me back up and explain that better. The independent variable is this campaign. And so we have to look at pre and post. The dependent variable is the gallons per month, and I've got two scores for that, two levels of it in pairs. My N is 11, and the first question I need to ask is, are the data normally distributed? Because I need to know if I have to do something with the data or transform it before I can actually run my my analysis. So I look at the skewness and kurtosis, and it's pretty obvious that they are well within the normal range. So I can say that the data are normally distributed. I'm ready to do my analysis now. The first step is to state your null hypothesis and your alternative hypothesis. Starting with the null. My null is basically that there's no change, or that the change is 0. And I would write that as the null hypothesis is such that the change, that symbol is a lowercase delta, and it means the change in the population. It isn't about the 11 families, it's about the population. So the mean in their fuel consumption before and the mean after, is the difference is going to be 0. There's going to be no change. My alternative hypothesis is that there is a change, or the change is not 0. So again, I would show that the alternative hypothesis is such that the change in the population, which is equal to the mean before and the minus the mean after, is not going to equal 0. The second step in my hypothesis testing is to set my criterion level. So I'm going to set it to 0.05. So alpha equals 0.05. So far, so good. Now I need to calculate my test statistic. And so I've got, this is what my SPSS screen would look like. I've listed out my 11 families. I have the gallons before and the gallons after. Here's how I do the actual analysis in SPSS. I go to Analyze, I am comparing means, and I'm going to do a paired samples t-test. When this box pops open, I need to move the variables over into the pair. I'm only going to have one pair. Don't worry about the row for two. I've only got one pair. I've got families and I've got before and after. So I move the fuel before the campaign over into variable 1, and I move fuel after the campaign into variable 2. I check the box for estimating effect sizes. And in my options, I want a confidence interval calculated that's at the 95% level, because I've got an alpha of 0.05. And this is what SPSS provides me with. Let's take a real close look at it. If we're going to calculate the test statistic, there's the formula. So I put the numbers in instead. Now my alternative, or my null hypothesis, said that the mean of the difference was going to be 0. The difference between the means is 2.546. The standard error of the mean is calculated with the standard deviation of that mean divided by the square root of n, which is 11, square root of 11. Or SPSS makes it real simple for me, and it gives me my standard error of mean. So I really just need to divide 2.546 by 1.021, and I end up with a t at 10 degrees of freedom is equal to 2.49. Or, getting even simpler, SPSS gives me that right there. It tells me what my t is and my degrees of freedom. So I have my test statistic. Now I have to decide what it means, whether I'm going to reject my null or not. This is where I use a chart. Here's my 0.05 significance level. Here's my 10 degrees of freedom, and I find out that my critical value is plus or minus 2.23. Remember, that 2.23 is that cutoff point off in the tails of the distribution of all the samples I could have pulled. And there's my area of rejection, and 2.49 is beyond that. It's off in the area of rejection. My null hypothesis was that there wasn't going to be a change, but I found that there was a significant difference between the mean fuel consumption before the campaign and the mean fuel consumption after the campaign. T at 10 degrees of freedom is equal to 2.49. So here's how I'd write it up. I would tell my reader that before the campaign, the fuel consumption was larger M equals 50.56, standard deviation equals 7.69. Then after, mean equals 47.91, standard deviation equals 7.89, by an average of 2.55 gallons per month. So I've told my reader the size of the change, 2.55 gallons per month, and the direction. It got smaller, so it was larger before the campaign. Then I would say, using the information from SPSS, the difference was statistically significant. T at 10 degrees of freedom equals 2.59. And notice that instead of relying on a critical value, I would actually use the information from SPSS. So I would say that it was statistically significant. P equals 0.032. Then I would look at the confidence interval. The 95% confidence interval is between 0.27 and 4.82. Well, that's further evidence that the difference in means was not zero, because zero doesn't fall between 0.27 and 4.82. And last of all, I'd say that the effect was a moderate one. So using Cohen's d, see the little d hat is equal to 0.75. And I got that information from the chart, the rule of thumb chart. So I stated my hypotheses. I set my criterion level. I calculated the test statistic. And then I made a decision about the hypotheses. It's now time to interpret my results.